Hello, my name is Joseph, and today I'm going to be showing some of the hot loading stuff that I've been working on, basically to improve the development process, to speed up the development process. So here on the left, I have a terminal with Homegames core with master as of February 7th, 2021. Okay, so I'm going to just do simple npm run start over here, and then that's going to start up the game server, and then I'm going to do run start on the web server, the same thing. And now I have Homegames running. Pretty standard. This is kind of the regular workflow. If I wanted to go and change something, let's say I wanted to make this background red, I have Sublime over here, so I'm gonna say, okay, that's red. And then I'd have to go back over here to the game server, restart it manually, and then refresh, and now it's red. That's pretty cool, but it's not super fast, and it'd be nice if it just kind of changed automatically without me having to do anything. So instead of running npm run start, I'm going to run npm run develop, and that's going to run a custom hot loader script that we have, which is basically exactly that. And then on the website, I can run develop, and this is just running Webpack Watch, which is kind of a build. It's a functionality of Webpack. We didn't write that. We didn't build that. But basically, this is for hot loading the actual client. So if I wanted to, I can go and modify the client, and it would just kind of work when I refresh the page. But whatever. What I'm trying to show is the Homegames core one, the one that we made. So back over here. Oh wait, very important. I did not change my config. So in my config, I'm going to say hot load is enabled. And then now I'm going to run npm run develop. And over here, it's still red, which is great because we didn't change the actual file again. But now let's say, okay, I don't like red. I want it back to normal. So you can see there on the right, it just kind of automatically refreshed when I made the file change on the left. So again, let's say I want to go back to red just to compare it again. I'm going to hit Command S to save, and then the hot load server. It's a simple WebSocket server, just sending messages to the client to say, hey, refresh, whatever, when it gets a new file change, and those file changes are just watched by that hot load script that I mentioned. It's basically just looking at each file every second or so and saying, okay, I found something different. Let me tell the client to refresh. So again, that's all that's happening now. I can do more complex stuff than just changing colors. I can say, I'm going to add a log to the constructor here in the dashboard. So, hello world. And then this probably refreshed and we just didn't see it. But if we go to the logs, we'll see hello world. So the process is much faster now with this npm run develop script. I don't have to go manually refresh stuff in the command line or however I'm running my process. I kind of just get to focus on the actual code. It's not fully done yet. Like if you do something that syntactically does not work, you'll just get this, and then you're kind of screwed until you manually fix that, and then you have to go and manually refresh. So basically only save the file if you know it'll work. All right, so the next thing I'm going to show is the ability to have a custom behavior for a spectator of your game. So I have that other video where I talked about the ability to spectate in the sense that you can just kind of flip it on and off. To demo that again really quickly, here's the player visibility test, or I can say, show me the text versus don't show me the text. And over here, I'm going to do the same thing, just join the game, do the same thing. But then this button here, which you can't really see because of the aspect ratio on my screen, but I can switch to be a spectator. And you see here it says hello spectator because basically we have the ability now to say, for the game to say, instead of the default kind of public view that a spectator would get, which is kind of built in for every game, instead of that, here's this custom ID. And so instead of the public view, give the spectator the view of everything that has this player ID. Basically like a pseudo view for a fake person who isn't there for the spectator view. So only the spectators can see this hello spectator text here, but if I start to join, or if I just join the game again, kind of back to normal, I can just show and hide this text. But again, back to spectator, and I can do that. So that's just kind of the basic change that we made there. And then for the next thing, we have this new settings gear. I drew this like on a tablet, and it's pretty bad. It doesn't look great. The colors are rough. Anyway, work in progress. But when you click this, you see kind of the standard things, but you also see this 8 of 8 assets and all assets downloaded. And so the reason for that is basically every game has the ability to declare assets. Basically, some like I have this image at this URL, or I have this song at this URL, and I'll depend on them in the game and reference them at some point. And so one of the changes that we made recently was making all those assets static. It used to be associated to the class, and so you needed an instance of your game to actually get the assets, which made no sense because they're static, they don't change. So with that change, we're able now to say, without the instance of a game, we're able to say, okay, well, across every game, we have 8 assets that we would need to cache if we wanted to, let's say, play this offline. Basically, take all this stuff off the actual internet and still have Homegames working with the server able to serve these assets, and that's what this would be. So I can kind of show what that would look like if I deleted a bunch of assets. So I'm deleting everything in the asset cache. And I'm restarting the server, and when I go back, all these assets are half loaded only on the first time after coming back. I don't know why yet, but that's consistent. So anyway, now I think 2 of the assets that games have are also declared as assets in the dashboard. So because we're in the dashboard now, there are 2 assets available. And so if I were to go to the image test, actually no, I think that's one of the ones with the shared assets. If we were to go to the sprite test, which has all of these little, images, which I think is like 5 or 6, however many, for this little animation. But anyway, if we go back now, go to settings, we have 7 of 8 assets because now we've downloaded all these, the sprites from before. But we can also just click this and get every asset. So now if we wanted to, like I said, we could take this off the internet and keep going. It's kind of an offline mode, I guess, in a sense. All right, and the third thing I wanted to show, or the next thing I wanted to show, I don't know what order it's going to be in the video. The next thing I wanted to show is client type awareness. So something that Yazid and I have talked about for a while on the podcast is we want the ability to know what is the thing that connected to us. Does it have a touch screen? What's the aspect ratio of it? Is it a tablet? Is it a phone? Is it a laptop? That kind of stuff. And we don't have all that information quite yet, but we do get the user agent, which tells us, is this a tablet or a phone or a computer? And we're also able to get the screen resolution. So here I have just a standard, desktop view, standard view of Homegames. On the second tab here, I'm mocking an iPad Pro. So the game from the user agent thinks that this is a tablet. And then the third one is a phone. And so you see it looks terrible over here, but the aspect ratio is different. So here you get kind of a 16:9 view of the dashboard, but here you get one that's kind of squished to the actual aspect ratio of the phone. And that's basically one of the behaviors that we've added here where we say, okay, well, if a phone connects, like on the dashboard, it's saying if a phone connects to me, I can go and actually show you the code here. I think I call it device rules, which is a bad name. Yeah, this is a super hack too. Okay, so device type, we get the player and we get the type of device that they're on. Kind of a little function callback thing that happens, I believe in the game session, when it notices that the player has sent it some sort of information about what it is. So if the player says, hey, I'm on a phone, this game is able to say, okay, cool. Well, if it's a phone, then give them a 1:2 aspect ratio. And so this receive update with these hard-coded numbers, basically the 9 is, hey, device, change your aspect ratio to this. And the first value here is the X, and the second is the Y. So it's a 1:2 ratio. That's what this 912 message is. Anyway, but the phone got this message here. And so it said, okay, I'm going to change my rendering stuff to be 2:1 instead of 16:9, which is what the tablet and computer got over here. And that's pretty cool. That's an example of just changing your aspect ratio. Another thing we can do, or an example, is this device test over here. So I'm on a desktop or, computer, whatever. It's a laptop. It doesn't really matter. And the screen is red. That's fine. And now on this fake iPad, we go to the device test and we join. And it's kind of this terracotta. What is that? That's not good. Anyway, so we get this. Because I needed to keep that up. Anyway, this is terracotta because it thinks I'm on a phone. So the logic I'll show you in a little bit, but is basically to do this. And then on the phone, this was a fake tablet, not a phone. Or why does it? Anyway, you get what I'm saying. Okay, so on the phone it's blue, on the tablet it's terracotta, and on a desktop it's red. So this is all the same game, quote unquote game. But if we go and look at the logic for the device rules, we can see. So device type, if desktop, then again, make a red block over their main view. If it's mobile, then make a blue block over their main view. And if it's anything else, in this case a tablet, then make it a terracotta view. And so again, that's what we have. Desktop view, tablet view, and phone view. Cool. So the final thing I want to show here is performance profiling. So I'm going to turn off hot loading. I'm going to turn off everything basically except for performance profiling. So now when I go back over here and I refresh, you'll see I have a new graph at the top here. And it's showing me some stuff. And then at the bottom, I have some other stuff outside of the main canvas. So all I had to do was set this performance profiling flag to true in my config and restart the server. The game said, okay, cool, I'm going to render this stuff at the top, and then I'm also going to tell the client when it connects, whatever client it is, to display some performance stuff as well. So we'll get to this stuff at the bottom, but for right now, this is from a NPM package I found that gives you some stats about the system, basically from the node process that you have. So basically from the main node process running all this stuff, we're using 14% CPU, basically since we only have that one thread. How much of that one thread are we using? 13% is the answer there. In terms of memory that we have available to us, we're only using 4%. I don't know why this is changing on hover, but whatever. And then this here, TTS, is time to squish. So basically the entire state of this dashboard, the entire tree, from the base with this frame and this logo and the settings button and all this stuff, the average time for each squish of that entire tree, which is the transformation of that tree to just a list of bytes basically, that's 1.5 milliseconds per squish. And so this number here is just saying if we were keeping the speed, we'd be able to do 640 renders a second. So the server here is moving pretty fast. If we had a client that was able to observe this fast enough, we would be able to get over 600 frames a second, basically, with this current performance. So if we wanted to see this get kind of bad, we can go to the performance test. And this is starting up a new graph because this is a separate node process with separate stats. So that's why this is all being collected kind of from scratch. And it's just built into every game. The game doesn't know that this is running. All I had to do, again, was just say, hey, collect performance data, and this stuff is running now. So you'll see we're not really memory constricted because each of these is 10 bytes or something like that. So overall this whole image is pretty small. Time to squish is getting fairly high, and we can see on the left here that we're basically maxing out all of our processing capability, and we can actually see that in the rendering of these blocks. All this thing is doing is rendering a new block every 20 milliseconds, 100 milliseconds. I forget what it is, but it's pretty visibly chugging here. We're maxing out CPU again, and it's just pretty bad. But if we go back, this is back to normal because these stats are for whatever it's running kind of in this container, which in this case is the dashboard. So hopefully that's pretty clear, kind of just basic. At the bottom here, we have kind of similar data. There's no labels on this because it's a very, very basic, just canvas graph that I made here. But basically this time here is saying from the time I start painting on the canvas to the time I finish painting on the canvas for a given render or kind of render cycle. This is the difference between, from when I finished to when I started. So on average, it's 3 milliseconds per render. So this number up here, okay, this is how often the game is rendering this stuff. So the game is saying, I have a state update, I can squish it and turn it into an array in 1.5 milliseconds, and I can send it. We don't have that data available here yet, but over the network, and there's some delay there. And then once the client gets it, and then the next time it has a render cycle and decides to actually render that data, that's what this number is here, the start to finish. And then the 60 FPS, I believe, is just, maybe it's some math. I forget how I'm actually calculating this. I think it's every 60 renders, it will say, okay, what's the average time of basically what's the time it took me to do 60 of these. And so it'll look back 60 frames and say, when did this one start? And then what's the time that the 60th frame ended? And then it'll take that average time and say, basically calculate this average FPS. So that's what it is right now. The client is rendering all this stuff at 60 FPS. So everything's pretty fast and performant on the dashboard. But again, we go to something a little bit crazier, like let's say go to Square. With all this movement and all these things kind of moving on these intervals, it's actually fairly expensive. See, the CPU is at 30, 32 there. But it's not maxed out completely like the performance test. It is getting worse as the game gets more complex, but nothing super crazy. But again, the whole point of this thing is just to help developers see how their game performs, maybe diagnose issues that they didn't know were there, stuff like that. So yeah, that's about it. And looking at my notes, that's everything I wanted to show for this developer update thing. Again, if you have any questions or comments or feedback or anything, let us know in the YouTube comments or on Twitter or whatever. And yeah, check us out at our website, homegames.io. Thank you.